Hi students, welcome to today's class. Today I am going to introduce a very important topic, that is continuity of a function. So far we have learned the limit of a function, the left hand side limit, right hand side limit. So we did various problems based on this limit of a function, and different concepts also we have learned. Infinite L'Hopital rule, 1 to the power of infinity type, 0 to the power of 0 type, factorization type, all and the formulas based limits, all we did it. Now what is the use of learning that limit of a function? The best use of the learning the limit of a function is to check the continuity of a curve. Here function means curve. Continuity of a curve. What is meant by continuity means what? So in our day-to-day life, we use the word continuity. Continuous means what? Without break. So we completed our course from 10th class, LKG to up to 12th class without any breaks. Understand? So we continuously completed. So in our journey also, if you want to travel from one place to another place without any breaks, we travel. That is called continuous. So given a function, for example, y is equal to x square. Y is equal to x square curve. So is it a continuous? Yes, it is a continuous. Then by seeing we can say that x-axis and y-axis. If you draw the graph will be like this. Y is equal to x square. It is a open upward parabola, passes through origin, lies entirely in first and second quadrants, and symmetric about y-axis. That means is it a continuous function means yes, we can continue. Yes, that means so without any break, the function is continuous. Everybody can say. But that mathematically how to prove it? So it may be continuous here at 1, 2, 3, 4. At 1 it is continuous, at 2 it is continuous, at 3 it is continuous, at 4 it is continuous. At certain points it is continuous. At if I ask you to find out 120, is it continuous? Who knows? I have to draw the graph up to 120. Yeah? So x is equal to 120, therefore 120 whole square. Up to that we have to draw the graph and we have to check whether it is a continuous or not. If I ask you to find out, check whether it is a continuous at minus 20, that means at minus 20 somewhere it will come. We don't know whether it is a continuous or not. Just by seeing up to only a little bit of the graph, we cannot conclude that the function is continuous. Okay now. So we have to mathematically give a general proof for the function y is equal to continuous at x is equal to a. A may be 1, 2, 3, 4 up to 120, 100, 2000, 2000, 5, this side minus 200, minus 300, minus 500, like that. So at x is equal to a, the function is, this curve is continuous or not. General proof you have to give, not a particular proof. If I ask you to find out, so at 120, then you can substitute here 120 here. Then we can draw the graph and we will check whether it will have a y coordinate and x coordinate, not like that. So we have to give the general proof. Now continuity of a function, there are here two cases arises. The one case is at a point. For example, if it is x is equal to minus 1, if you want to check the graph is continuous at a point means then we will check it here. We will check here. As it is a continuous or not, at that point is there any breaks or not, like that we will check. So that is means here two cases arises. What is means continuity at a point, at a particular point. We have to check whether it is a continuous or break. We have continuous or break. And the second one is in a interval. For example, 2 to 4. 2 to 4, what is the graph? So this is the graph. 2 to 4, it is graph. It is a 2 to 4. From 2 to 4, this is the graph. So that is we have to check the continuous in a interval. At a point, second concept is in a interval. Intervals. Okay, continuous at a particular point. The second one is continuous in a particular interval. Interval means again we have four types of intervals. What are the four types of intervals we have? Both are closed, let us call it as alpha, beta, otherwise A, B. So open and closed, second one. Both open. So this is a closed, right side open. Right open, left closed. Left open, right closed. Both open, both right. In these intervals, how to check the function is continuous. Okay, na? So those are the things that we are going to learn here. Okay, now I will ask you, sir, what is it is you have seen not only y is equal to x square graph, y is equal to x cube graph, y is equal to sin x, y is equal to cos x. These graphs are continuous. That means without any break, you can, without lifting your pencil, you can draw the graph to x tends to infinity. This side x tends to minus infinity. You can draw the graph. Understand? But whereas y is equal to tan x and y is equal to step of x, this is the greatest integer functions, they are not continuous. They are not very continuous. Why? Because at x is equal to 2n plus 1 pi by 2. That is odd multiples of pi by 2. Tan function will have break. Why? Because at tan pi by 2, it is not defined. Tan 3 pi by 2, tan 5 pi by 2. Coming to this side, minus pi by 2, minus 3 pi by 2, minus 7 pi by 2. So if you see, observe the graph, there you will have a discontinuity. That is called discontinuity. Breakage you will have. This step function is also, we know that, so it has a breaks. So here from 0 to 1, so 0 to 1 is 0 only. From 1 to 2, so here it will have a break. At exact at 1, at x is equal to 1, it has a break. Understand this? So that is why step function is also discontinuous function. So it discontinues at integers. At integers it is discontinuous. Why? Because so you have to draw the pen, so you have to lift the pencil and you have to draw again. Here you draw. So this is step function here, like that. So this is step function. So you will have a breakage here. Breakage at x is equal to integers, you will have a breakage. That's why it is not a continuous function. So before discontinuous function, so these are at a point the functions are how to check, how to verify at a point the function is a continuous. First we will take up this topic. At a point, at a particular point, whether the function is a continuous or not, that we have to check. Afterwards we will come to the intervals. Okay, now so let us see that at a point how to check a function is continuous or not. Okay, welcome to this concept that we are going to see continuity of a function at a point. Continuity of a function at a particular point. Okay, now then how to check whether it is a continuous or not. Let us take the function here x is and y axis, and it is origin. X axis and y axis origin. Let there is a function f from R to R defined as y is equal to some any curve. Let this be a curve. Okay, now right, any curve. We want to check at a particular place, at a particular, sorry, not point, at a particular, at x is equal to a, at x is equal to a, we want to check here continuous or not. You may ask one doubt, sir, it is clearly, no sir, it is a looking, it is a very clearly, it is a continuous. Okay, now, so since I am drawing the graph, you are able to say that it is a continuous. If you take a very big function, so not a big, not big, not small. If you take a function, there are certain functions are there which you are unable to draw their graph. So it's a very difficult to draw the graph. But for particular that type of functions, how to check whether the function is a continuous or not. Okay, now, so we are unable to draw some graphs. So since it is a very easy graph, then I have drawn the graph and check. Now I want to check the continuity of the function at this point. Whether it is a continuous or it's any break is there. For that, we have to check the left hand side limit of this function as x value approaches to a. That means what? Left hand side limit extends to a minus f of x. Limit extends to a minus f of x. This should exist. This should exist. Exist means what? You have to get a finite value. Already we explained what is a left hand side limit, how to find out the left hand side limit given a point. Okay, now second one, so this is the first one you have to do. Second one, right hand side limit to find out at x is equal to a plus. So here at x is equal to a plus. So here right hand side also, right hand limits I also find out. This also should exist. This also should exist. Exist means what? You have to get a finite value. That is the second one. Third one is at first you have to find out this one by one. So this is left hand side limit, right hand side limit, and the third one what you have to find out is at x is equal to a, the what is the value of f of x. At x is equal to a, what is the value of f of x means what? F of a value you have to find out. F of a value, so this is called functional value. So if you substitute x is equal to a in the given function y is equal to f of x, you will get output. Simply you will get output. If you substitute x is equal to a, for example, this is a x square, a square is output. If it is a 2x plus 3, 2a plus 1 is the output, that value. Understand? If it is a 2, if it is a something 2x plus 1, if it is f of 2, 2 2s are 4, 4 plus 1, f of 2 is equal to 5. This 5 value. Understand? So at x is equal to a, find out f of a value. So now the calculation part is over. The calculation part is over. What you have to convert, what you have to find out? You have to find out left hand side limit at x is equal to a, where you want to check. You have to find out right hand side limit at x is equal to a, where you have to check. Next one, their both limits exist. They both should have a finite value. At x is equal to a, find its functional value, image, otherwise we can call it as an image of the point x is equal to a. So after calculation part is over, now the observation part is games. What is the observation? So the practical part is over. So this is the practical part over. Now the theoretical part starts. Now the theoretical part is, if a function is said to be continuous at x is equal to a, if a function f of x is said to be continuous, is said to be continuous at x is equal to a, function is said to be continuous at x is equal to where a belongs to the domain of this function. This is understood because in the domain itself, so where this is a very important, where a belongs to domain of the function f of x is said to be a continuous function if and only if, we can write down by conditional statement, if and only if limit extends to a, f of x is equal to f of a. Limit extends to a, f of x is equal, limit extends to f of x is equal to f of a. What is the meaning of this? Limit extends to a, f of x will be this exists when left hand side limit is equal to right hand side limit. When x tends to a, x tends to plus minus. That means these two values should be equal. Left hand side value, right hand side limit, left hand side limit. These two should exist, and not only simply exist, these two values should be equal. That means if it is a 5 by 2, this also should be 5 by 2. It is a root 2, this is also root 2. It is 0, this also should be 0. It is 5, it is also 5. If it is a root 2 plus 1, this is also root 2 plus 1. Understand this? If it is a 1.5, this is also 1.5. Exactly same. It should be exactly same. Then we say that limit extends to a f of x exists. Whatever may be the value you get, here f of a value also should come same. That means if it is a 5 by 2, this also 5 by 2, this also 5 by 2. If it is a 6, 6, 6. If it is a root 2, this is also root 2, this is also root 2. That means 3 values should be equal. Left hand side limit at x is equal to a, right hand side limit and at x is equal to f of a value. All these 3 values should be equal. So if you check from left hand side, if you check from right hand side, if you go up from left hand side, from right hand side, if you go up, everywhere that you have to get the same answer. You have to get the same answer. Then only we can say that the function is continuous at that particular point x is equal to a. Understand this? If any of this case fails, we simply say that the function is not continuous at x is equal to a. Any of the case. For example, this exists. And its value is root 2. Right hand side limit also exists. Its value is root 2. But at x is equal to a, f of value is a 2. Then we say that at x is equal to a, the function is not continuous. Simply we say that it is a breakage is there. Some breakage is there at the point x is equal to a. It is not discontinuous. It is discontinuous. Understand? Okay. It is root 2. It is also root 2. But it is a 2. Then the limit x is not exist at x is equal to a. Then also it does not exist. Understand this? Okay now? Right. It is a root 2. This is root 2. Here the limit does not exist. Sometimes there are some formula limit does not exist. Limit extends to a plus. That means right hand side limit does not exist. Then also the function, the curve is not continuous. The curve is not, curve means function here. The curve is not continuous at x is equal to a. That means, so if the curve is to be continuous, it should be left hand side limit, right hand side limit and the functional value at x is equal to. If you want to check x is equal to a, so you attack the function from left side, right side and go up or down. Of course, not up. Sometimes if there is a function is in the below the x-axis, you have to come down. You straight away attack the function that all the 3 values should be equal. All these 3 values should be equal. Then only we say that the function, the curve is continuous at that particular point. Okay, so are not bothered about the left side, right side. So at that particular point, the curve is continuous. Understand this? So I hope that you understand this concept. At a point I am discussing. Okay, now we will see a little bit small problems to understand this continuity of f. So immediately after learning some theoretical problem, theoretical concept. So if you do 1 or 2 problems based on that, definitely you will have a grip over that concept. Okay, so let us start a very small problems. Okay, welcome to this problem. See here, test the continuity of the function f of x at x is equal to 0. At x is equal to 0, we have to test the continuity of this function f of x. This is called branch wise function. So, but at x is equal to 0, the function f of x is defined as 1. That means at x is equal to 0, the function is taking the value 1. When x is not equal to 0, that means for x less than 0 and x is greater than 0, the function is taking this graph. Now see here, now can we draw the graph for this? See here, So previously we can draw the graph y is equal to x square, y is equal to sin x, y is equal to cos x, y is equal to e power x, y is equal to a power x, modulus functions, sigmoid functions, all those types of graphs we can draw at a certain extent, we can draw some certain extent. But can we draw the graph of this x plus 1 to the power of 2 minus of 1 by mod x plus 1 by x graph by taking a table, allotting some this is of x is a independent variable, y is a dependent variable. So taking some x values, can we draw the graph? Answer. So it is somewhat difficult to draw the graph. So without drawing the graph, we have to test the continuity of the function x is equal to 0. Okay, na? So for that, so what are the things? So three values we have to find out. One is what? At x is equal to 0, left hand side limit. At x is equal to 0, right hand side limit. At x is equal to 0, the functional value. Already this functional value is given, f of x is equal to, so therefore f of 0 is equal to 1. Okay, na? So now let us start this problem. So first to find out the left hand side limit. Okay, na? So as solution, at x is equal to 0. So we are left hand side limit, that is a limit x tends to 0 minus. So for x not equal to 0, that means what? If x is equal to less than 0, the function is defined as same. For left hand side 0 and right hand side, the same function is defined as same, that is equal to x plus 1 to the power of 2 minus 1 by mod x plus 1 by x. Okay, now. So this value now we are going to find out. Okay, we are going to find out. Now let us check the function here. So let us convert this problem into h, where h is a infinitesimal. Already we discussed very small problem value. So as x tends to 0 plus, let us check h tends to 0. H tends to 0. So in place of x, we will write down 0 minus h. 0 minus h. So why? Because here 0 minus h plus h. Wherever x is there, we will write down 0 minus h. 2 to the power of 1 by modulus of 0 minus h plus 1 by without modulus 0 minus h. Let us check this value. So this is equal to limit h tends to 0. This is a 0 minus h plus 1. This is a 1 minus h, 2 to the power of. So here modulus of 0 minus h, modulus of minus h, modulus of minus h means h. So this is 1 by h. Okay, now. So 1 by 0 minus h, this is a minus 1 by h. So this plus 1 by h minus 1 by h we can cancel. Why? Because here h is an infinitesimal value not equal to 0. So what are the things that remains here? So this is equal to limit h tends to 0, 1 minus h, 2 to the power of 2 minus 0, 2. This is a 2. As h value tends to 0, 1 minus 0, 1, 1 square, 1. Okay, now. So this is a left hand side limit. What is the left hand side limit value is 1. Now let us find out the right hand side limit. So limit x, okay, we can 0 plus, no. So let us, can I write out directly h? Can I convert into h? So here limit h tends to 0. Here in place of x, what you have to write down? 0 plus, no, 0 plus h you have to write down. 0 plus h. 0 plus h. 0 plus h plus 1. Plus 1. 2 to the power of 1 minus 0 plus h, of course modulus plus 1 by 0 plus h plus h. So this is equal to limit h tends to 0. This is a 1 plus h whole to the power of 2 minus, as usual, modulus of 0 plus h is equal to 0 plus h is h, modulus of h is h. So this is a 1 by h, this is a 1 by h, this is a 2 by h. 2 by h. Understand this? So 1 by h plus 1 by h, 2 by h. See here, as h value approaches to 0, as h value approaches to 0, 1 by h value approaches to, as h value approaches to 0, 2 by h value h value tends to 0, 2 by h value approaches to infinity. It is approaches to infinity. So that means what here? 1 to the power of infinity you are getting. So when you are getting 1 to the power of infinity. So when you are getting 1 to the power of infinity, so we know the e to the power of raising the powers, and all those things we know. So without using this, but this particular problem we can do easily. So limit we can write down h tends to 0, 1 plus h whole square by limit h tends to 0, 1 plus h whole to the power of 2 by h. H tends to 0. This is h tends to 0. So that means a power m minus n is equal to a power m by a power n. Okay now. So it is a very clear. So in the numerator, h tends to 0. Wherever h is there, substitute 0, 1 plus 0, 1 square, 1 by limit h tends to 0, 1 plus h whole to the power of 2 by h. 1 plus h whole to the power of 1 by h is a e. So we are getting e square. Understand? So this is equal to how much? Right hand side limit. So very clear. The left hand side limit is 1. The right hand side limit is 1 by e square. They are nowhere equal. They both are not equal. Okay now. So therefore at x is equal to 0, no need to check whether f of x is equal to 0 now or not. That is a different field. First of all, LHL is exist. Right hand side limit is exist. Both are exist. Both have getting some value, finite value. But they are not equal. Therefore, at x is equal to 0, the limit does not exist. At x is equal to 0, the limit of this function does not exist. Therefore, it is not continuous. It is not continuous at x is equal to 0. That means what? If you draw the graph for this function at x is equal to 0, definitely you will have a break. Understand this? Definitely you will have a break. So this is the way of checking the function is continuous or not. So here, whenever here modulus k, modulus of x or step of x or signum function of x is there, definitely you have to find out left hand side limit and right hand side limit. Why? Because for modulus function will be this behavior will be modulus function, signum function. Their behaviors will change from for x less than 0 and x greater than 0. The behavior will be changed. Okay now? That's why. So this function is not continuous at x is equal to 0. So this is the way of proving that. Okay now? So particularly here a power m minus n, a power m by a power n. Otherwise 1 to the power of so it is as h tends to 0. So this is 1 to the power of infinity type also you can do here. Okay. So I hope that. So here easily we can cancel here. H will get cancel. Right. So e square easily you will get. So if you can do this, this is equal to e to the power of limit h tends to 0. So this is 2 minus 2 by h will become as a this thing, and you will get the answer. Okay now. So I hope that you understand this solution. So let us move one more problem. Welcome to this very interesting problem. So there is a function defined as f of x is equal to x square if x belongs to minus infinity to 2 less than or equal to 2, and 3 if x is greater than or equal to 4. So for you that graph also I have driven. So from minus infinity to 2, the function is a parabola. If x is greater than or equal to 4 and 4 and more than 4, that means here x is equal to 4 and more than 4, the function is x is equal to 3. The function is x is equal to 3. That means y is equal to 3. It is take a straight line form. Now my question is, if f is a continuous function or not? F is a continuous function or not? So check this problem. Majority of the students, they will give wrong answer. They will give wrong answer. So if you are intelligent enough, so say yes or no in the comment box. Okay now? So in the comment box, yes or no you write down, and please comment in the box yes or no. If it is if I am very happy if you write down the explanation also. If it is yes, why it is a yes. If it is a no, why it is no. Understand? Write down. Please clearly write down. I hope that you are very smart enough. Definitely you know the answer. You have, if you see the concepts what I have taught, definitely you will write the correct answer. Okay, so this is a challenging for you. So write in the comment box whether it is a continuous or not, yes or no. Just write down yes or no. If you are I'm very happy if you write down the explanation also, why it is not continuous, why it is, if it is a continuous, why it is continuous, if it is a discontinuous, why it is discontinuous. So let us write it, and I hope that, so definitely you will write the answer in the comment box. Okay na? So let us see some more concepts in the tomorrow's class. Until then, all the best.